I'm going to go over solving quadratic equations by completing the square. And so before I get to actually solving an equation, I want to talk about what it means to complete the square. So let's say that you have two terms of like x squared plus 10x. And I want to add, I left off my x squared plus 10x. I want to add a number, a constant here, so that I will create a perfect square trinomial. And so a perfect square trinomial is one that can be factored into a binomial square, just like a perfect square number is one that, like 16 is 4 squared. So to find the number that I want to add here to create the perfect square trinomial, I look at the linear term, and the coefficient of x is 10. You take half of 10, which means you divide it by 2. Half of 10 is 5, and that's what you want to square. And 5 squared is 25. So this is a perfect square trinomial. Now it's very easy to factor. The first term is a perfect square, the last term is a perfect square. You're squaring x to get x squared, so that goes first. You're squaring 5 to get 25, so that goes second. And you take the first sign in the trinomial. So that will factor into x plus 5 squared. All right, let's look at another one. Suppose I have x squared minus 12x. And I want to add a number here to create a perfect square trinomial so that it will factor into a binomial square. So I'm going to take half of 12, which is 6. It doesn't really matter that it's negative because you're going to square it anyway, and this is always going to be positive. So half of 12 is 6, and 6 squared is 36. So my binomial squared is going to be x, and this time it's minus because that sign is minus, so factor into x minus 6 squared. Now, 10 and 12 are both even numbers, and so it's easy to take half of 10 and half of 12. Let's look at one with an odd number. Let's say we have x squared minus 7x, and I want to add a number here to get a perfect square trinomial so that it will factor into a binomial square. So this time, I've got an odd number. I have to take half of 7. Well, that just means I'm dividing it by 2, and it's better to leave it in fraction form because we want to square 7 halves. And when you square a fraction, you square the numerator. 7 squared is 49, and you square the denominator. 2 squared is 4. So the number I'm adding is 49 over 4. But it is still easy to factor because what we're squaring first is x. Take that first sign, and what did we square to get 49 over 4? 7 halves. That's what goes second in your binomial. So it's x minus 7 halves squared. Okay, so we're going to be using this in solving by completing the square. Let me get down, get this little line off of here. So now let's look at an actual equation to solve. Oh, sorry, this thing does crazy things. So we're going to solve by completing the square. So the first one I want to solve is x squared plus 8x minus 4 equals 0. Now this particular quadratic equation will not factor. It's not the right form to use the square root property. But completing the square is another option. And let me say this, that you want to make sure the coefficient of x squared is 1 if you want to complete the square. If it's not, you probably want to try another method of solving because it just gets too complicated. So this minus 4 didn't help me out any. I want to leave x squared plus 8x on the left side, and I'm going to add 4 and bring it over to the right side. Just get that constant out of the way. So I left some space here because remember we're going to complete the square. So you want to go to the linear term, which is 8x, take half of 8, half of 8 is 4, and square it. 4 squared is 16. So add 16 on the left side, but since this is an equation, I have to add side should factor into a binomial squared, and it does. X plus, we squared 4 to get 16, so the x plus 4 squared, and then 4 plus 16 is 20. Now, this should look similar to the ones that we did solving using the square root property. We've got a binomial squared on the left side and a constant on the right side. So take the square root of both sides. The square root of the left side is x plus 4, and the square root of the right side, remember, positive and negative square root of 20. So I need to finish this by getting x by itself. So let me get a little room here on this and see if I can come across. So I'm going to subtract 4 from both sides. So x is equal to negative 4 plus and minus the square root of 20. But remember, you simplify your radicals. The square root of 20 is the square root of 4 times the square root of 5. And the square root of 4 is 2, so you want to bring out that 2 comes the square root of 5. So our two solutions are negative 4 plus 2 square root of 5, and the other one is negative 4 minus 2 square root of 5. Okay, let's do one where you're going to have a fraction. Okay, sorry. The second one, let me just move away from this. Try again. Okay, the second one that I want to solve is plus 1 equals 0. And so again, you see this will not factor, and it's not in the right form to use the square root property. So I'm going to move the 1 up. So I want x squared minus 5x. That means I have to subtract 1 when I take it to the other side. So I've got to add a number here to create a perfect square trinomial. Well, we have a fraction. This is 5. We're going to divide it by 2 and square it. So when you square the numerator, you get 25, and when you square the denominator, you get 4. And so I'm adding 25 fourths to the left side, and then 25 fourths to the right side. The left side will factor into x minus, remember what we squared to get 25 fourths was 5 halves squared. And then I've got to add negative 1 plus 25 over 4. Now you can pull out your calculator, whatever you want to do, but there's a quick way to add an integer and a fraction. I know my denominator is going to be 4. So to get the numerator, I'm going to multiply the denominator times that integer. 4 times negative 1 is negative 4. And add negative 4 to 25. Negative 4 plus 25 is positive 21. So negative 1 plus 25 fourths is a positive 21 over 4. Okay, we want to take the square root of 5. X minus 5 halves is equal to positive and negative square root of 21 over 4. Now, I put the entire thing under the radical right now. And so I want to get x by itself, which means I need to add 5 halves to both sides. So I'll bring over the 5 halves, and then plus and minus. The square root of 21 over 4 is the same thing as the square root of 21 over the square root of 4. We cannot simplify the square root of 21, so it has to stay under the radical, but the square root of 4 is 2. So my two solutions are 5 halves plus the square root of 21 over 2, and 5 halves minus the square root of 21 over 2. Or, since they have a common denominator, you could write the answers as 5 plus the square root of 21 all over 2, and then 5 minus the square root of 21 all over